Hey guys, so mostly I've showed you guys looking at Jupiter and Saturn through refractors and apochromatic, that type of thing. Now I wanted to show you guys this guy. I showed it like an unboxing and then more in depth, the Meade 10-inch f4 reflecting telescope. However, I wanted to show you guys what the planets look like through a 10-inch telescope. So that's what we're going to do. Anyway, I'll see you guys in 1 minute once I just get myself set up. Okay. What's nice about a reflecting telescope like this one is I got the Duke app on right now, but I have it on the EQ6 on its most lowest, and the eyepiece is in a perfect position. This is also the angle I'm probably going to be viewing at, because the planets are south, and this is what you hear all the time, that a big reflector on an EQ mount has such weird angles. And it's just so simple, guys. You just twist it like that, bada boom. Now it's probably a perfect angle for me. This time I am using a finder scope, the wide gel. Okay guys, I had to close a couple curtains because it actually was putting glare in my eye, and I also had another problem, that maybe this focuser doesn't reach focus like at all. So I believe I need an extension tube now. The problem is I don't have an extension tube. So I'm going to show you guys what I did to kind of get away or fix this problem. So I had an extra, like cheapy-ish bar, not too cheap, but you know, like a $30, $40 Barlow. And I don't know if you could see here. So what I did is I took out the bottom lens. So basically it's just a hollow tube. Now that 3-inch is perfect. So I'm gonna use my 4 radian, which gives me about 254 power. And so anyway, so I can reach focus. So I didn't realize that maybe this low profile focuser. Let me see if I can adjust the light sensor a little bit more. No, that's the highest. So I didn't know that this scope needed an extension tube with this focuser and combination, but I'm glad I fixed that problem, because otherwise I would have had to call it a night, because I don't even have an extension tube. So either I am going to just order an extension tube, or I can just keep that Barlow whenever I want. I do have a Meade Barlow, the 5000 2 times, but the problem is this one will not work, because even if you take out the lens like I did in that little cheapy one, because this is a triplet Barlow, there's actually a lens still inside there, so it won't work if I use this type of Barlow. You just got to use like a regular Barlow that's just a doublet, one of the cheaper ones that you could probably find between 20 and 40 bucks, 50 bucks, even a bit more. So this kind of Barlow, it's too bad it wouldn't work, because then so I can order an extension bar, 2-3 inches, that would probably work, or just keep that a little bit cheaper Barlow and just use it as a Barlow, and when I need an extension tube like this guy, just pull out the lens. Anyway, let's take a look at Saturn here, 254 power. Now it is kind of zipping by, so which means it's plugged in, it's tracking. With the EQ6, the only problem is I think my polar alignment obviously is a little bit off, because I can't really see it anyway. So I always guess. So let me see if I can show you guys what Saturn would look like in a 254 power. Sorry, what I'll do is I'll tell you what I see in 254 power, but putting the cell phone to this kind of power is probably not gonna work. I'm gonna lower the power and then just blow it up a little bit. Okay, so here's what I do see. It is nice and bright. This is a moonlight focuser. So it has a dual speed. It's a nice smooth focuser. At this power, it is nice and bright. I can see a couple moons on the left and the right. But you know what? It's not as crystal clear, and I did collimate it, just in case you guys were wondering. And when I defocus in and out, it's not 100% perfect as far as the donut, but it's very symmetrical. Not 100%, because I did collimate it inside. I didn't collimate it on a star today, but today's a little bit windy, so that wasn't sure if I was gonna do it today. So, okay, let me see if I can show you guys what I see. Okay guys, so like the refractors, I have 133 power. It might be actually a little bit more because now the extension tube is probably adding, I don't know, 50, 60 millimeters. But anyway, it's an 18 millimeter super wide Meade, Japan made, 4000, so it's a good eyepiece. And it's a 2 times Meade 5000 Barlow. So again, it's so about 133 with the extension tube. We're probably hitting about 140, 145. So this is the image I get. So the same powers. Let me see if I can just get that a little bit centered. So you tell me what you think in a reflector. Let me. Now today's a little bit windy. Again, I don't know if I'm 100% collimated, but it's mostly good. But you know, in an F4 system, you know, well, it's probably F5, F5.5 with the corrector plate, but that's what Saturn looks like. Okay, another quick video of Saturn there. I can't really see the Cassini division. I think that's where, you know, people like me and other people that are really serious planetary viewers, you want to use a refractor. It's just the cleanest image. You don't have to worry about collimation at all. It's the sharpest, most contrast. But I guess for a reflector, it's pretty decent. Okay, let me see if I can show you guys Jupiter quickly. And again, guys, remember too, the image is much cleaner in the eyepiece. It's 10 times better, at least. Okay, I'm just gonna look one more time visually for me. I'm just gonna back down the power with a 5 radian, which gives me 203 power with the extension tube, maybe 210 power. And let me just see what do I get. Yeah, it's not bad. It's actually clean. I mean, most new people that were to see this were like, wow, okay, I can see a couple, 3 or 4 moons of Saturn. Now, I could be slightly off because I don't have a chart telling me exactly where the moons are right now. So they could be stars in the field of view, but a couple of them are at least moons. The Cassini division, not too much. Now, again, it could be the seeing. It's a little bit windy down here, so it could be very windy up there in the atmosphere. You know, who knows? So it's hard to judge what one was like 2-3 weeks ago and what I'm seeing now. The only way really to do it is if let's say if I had a refractor right now and they both cool down at the same time, or this one a little bit longer because it's larger, and then let's see what the image would be in each eyepiece or each power. Then okay, I see. Then we can kind of compare exactly. Okay, this one's sharper, type of thing. But you know, we can't go off by memory. It's decent view. Any new person would be like amazed to see Saturn. It is bright because it is 10-inch. I even see banding on Saturn, so it's not bad. However, I still think the refractor is sharper. Now, here's what we're going to do. Let's take a look at Jupiter, and then I'm going to tell you what do I think. I'll be back when I show you guys Jupiter. Okay, so you can see again I'm at the same power, 133, maybe 145 with the extension tube. Now Jupiter is overexposed, that's why you see it bloaty, but I want you to see the 4 moons all on the left side. There, you can now see it on the edge. Of course, I'm overexposed on Jupiter. Okay, a little bit strange about this moonlight focuser for this model is I don't see the locking nut, because what's happening is now that I have a 2x Barlow, an extension tube, the camera adapter, my cell phone, even though it's not that heavy, I don't see no locking nut, so it doesn't unfocus. And I think that's what's going on right now. I do see a couple like Allen nuts at the very bottom, but I wonder if that's where it should have like thumb screws to lock it in, and then it doesn't move. But anyway guys, there's Jupiter. I can't make it any better for whatever reason. Okay, that looks pretty good just looking at the cell phone from here. You guys tell me what you think. Jupiter and the reflector. Okay guys, the next time I use this Meade 10-inch reflector, we're gonna try something out. I've heard this several times on the internet. Why would somebody buy a expensive 4 or 5-inch apochromatic instead of buying like a 10-inch Dobsonian, where you're gonna have, 10 times the light gathering power and 10 times the definition, or sorry, the resolution. So we're gonna try that out. My thinking, what it's gonna be, the reason why, is the 10-inch is gonna collect more light. It's gonna be more brighter. So maybe the bigger detail is gonna stand out more, but in a refractor, an apochromatic refractor, even though it's smaller, it's gonna be razor sharp. And the small, fine detail that you can't see in a reflecting telescope is gonna come out in a refractor type, or an ED, or an apochromatic. So that's my thinking, and we're gonna answer that question why. So here's what I'm gonna use. The 10-inch Meade Schmidt-Newtonian against my 5.1-inch, the 130 millimeter 600 series Meade triplet refractor. That's half the size. So is it going to be a half a size triplet refractor? Is it going to be sharper, more detailed? What would somebody prefer looking at the planets, if you're serious about looking at the planets? Now, that guy would probably blow that guy away when you're looking at nebulas and galaxies, sure. But now we're talking about the planets. What would be better? And then maybe what I'll do is take something like an entry-level 6-inch or the 7-inch Meade that's on my bed right now, because I'm using the EQ6 outside. We can try like the 6-inch Skywatcher or the 7-inch Meade and get a slightly closer light collecting ability of a refractor to the 10-inch. We'll try that. Anyway, Joe Jaguar, like, comment, subscribe. I'll see you guys in the next video.